I am Carlos Colares, Assistant Professor at Maastricht University, working on the Erasmus Plus project entitled Online Adaptive International Progress Test. Have you ever wondered how we learn? Which learning strategies do you prefer? What is your favorite one? To highlight, to underline, to read again, or to summarize? Well, if any of those strategies is your favorite one, then I believe I have bad news for you. Dunlowski and his colleagues have reviewed more than 700 papers, and they found out that these strategies have low to moderate effect on learning. Which was the number one? Testing yourself. The problem is that most people just study for the test, usually cramming a couple of days before, not for their professional lives, and then they forget. This is why the progress test was created more than 40 years ago. The idea was to deliver a longitudinal assessment strategy that could be more compatible with modern education. In the progress testing framework, all students from all academic years do the test, which covers all contents from the curriculum and minimizes the study for the test phenomenon. I dare to say that progress testing not only assesses, but also promotes deep, meaningful, and long-lasting learning. But the progress test has not only advantages. One of the obstacles for the optimal use of progress tests has to do with reliability. But first I have to explain what it is. Well, differently from a thermometer or a clock, whose nature of measurement is pretty much direct, a written test has a much more indirect nature of measurement. If you get 5 out of 10, for example, can you really say you knew just 50% of the content? Well, this depends on many factors, such as whether the content coverage was adequate and the difficulty of the questions in the test. Reliability sometimes is also called precision, reproducibility, or even internal consistency. In any case, it is a way for us to understand how much the test scores are free from that indirectness, or let's say noise. In other words, reliability tells us how much signal the test scores have in comparison to the sum of noise plus signal. This means that values can go from 0 to 1, and if they are below 0.5, it indicates that the scores have more noise than signal. While you can aggregate the reliability of several tests during an academic year to reach good reliability levels, isolated progress testing scores on early academic years can have that problem. In this table, if you look at the coefficients in red, you can see that first-year students have quite low reliability levels in their progress test scores, if you think about isolated measurement moments. So in order to increase reliability and metacognitive skills, sometimes progress tests impose a penalty for wrong answers, which depend on the number of alternatives of the question and the addition of an I don't know option, so that the students can skip the penalty if they don't know. This was indeed beneficial to reliability, but at the same time, it introduced bias in the form of what we call construct irrelevant variance. Apparently, students with partial levels of knowledge but low levels of self-confidence or even high levels of aversion to the risk of the penalty ended up in disadvantage. Furthermore, this kind of scoring framework induced students to cherry-pick the questions, preferring shorter ones, the ones with more alternatives and lower penalty, the ones in the beginning of the test, and also rejecting questions with clinical cases, exactly the ones with more professional authenticity and therefore more predictive validity. But the basic problem was still the mismatch between the knowledge level of the test takers in early academic years and the difficulty of the questions, also known as items. If the test is far too difficult for the knowledge level of the test takers, the tendency is that reliability will be low. And the opposite is also true. If the test is too easy, reliability will also likely be very low. When there is a good balance between the difficulty of the test and the knowledge level of the test takers, then reliability is optimal. Another problem occurs because progress tests aim at the end of course level of expertise. And that's why some medical teachers are skeptical about the utility of progress testing. They claim that progress testing violates the principle of constructive alignment, the alignment between what is given in the curriculum and the assessment. So, around 10 years ago, I thought, what if we could increase the reliability of progress testing for students in the early academic years by adjusting the level of difficulty of the test to the knowledge level of the test takers? To understand how that is possible, I need to invite you to open your mind and accept the idea that under a certain probabilistic model, it is possible to put both things, the difficulty of the items and the knowledge level of the test takers, in the same scale, like the seesaw I showed you before. So let's look at Johnny answering item 7. Item seven's difficulty is lower than Johnny's knowledge level. So the probability that he will get a correct answer will be more than 50%, right? And the same is true for item 8. Johnny has a lower knowledge level than the difficulty of item 8, so the probability will likely be lower than 50%. And what if I had another item called item 9 that had the same difficulty level of Johnny's knowledge level? Yeah, the probability of a correct answer for that question and Johnny would be 50%. And that is exactly what the algorithm behind the computerized adaptive testing engine does. After each one of the test taker's answers, the algorithm tries to find questions whose probability for a correct answer will be as closest as possible to 50%. Other rules also feed the algorithm to ensure the highest possible test quality, such as following the test blueprint to keep the content validity of the test, as well as not repeating the same questions over several tests or the same topic on the same test. The difficulty of the items that compose the item bank has to be known beforehand. This demands a phase of pre-testing, or the analysis of previously administered items using the hash model, which formula you can see above. The process of estimating the difficulty parameters of each item is called calibration, and they are calculated using item response models, which uses a series of logistic functions to establish a formal relation between the difficulty of the items, the knowledge level of the test takers, and the probability of a correct answer. The logistic curves on the left of the spectrum represent the easiest items, the curves on the right the most difficult ones. In other words, the difficulty of the questions are taken into account when calculating scores for this type of test. Everyone starts the test with a clean slate, but as the test progresses, the computer algorithm starts to estimate your knowledge level and deliver items with a difficulty level as closest as possible to it. The first adaptive progress tests were delivered in Brazil in 2010. Since then, they have been applied in many countries such as Mexico, Finland, Georgia, Saudi Arabia, and the Netherlands. In all these places, reliability levels have been very high, around or above zero point 0.9, regardless of the student's academic year. But the most important thing was not reliability. In Finland, I discovered that the most important thing was the alignment of this kind of test with modern learning theories. And this has been developed. But is the alignment of adaptive testing to modern learning theory sufficient? What does the empirical evidence say? Well, there weren't any robust studies about the effects of computerized adaptive testing on students until this paper from 2018 demonstrated that students doing an adaptive test had a better subjective testing experience, better motivation, better engagement, and sometimes better performance in comparison to students who had done traditional tests on paper. But the study was done in Australia and not with a progress test. Will these positive effects be seen also in medical students? That is why 8 European medical schools have gathered forces to create a GDPR-compliant online adaptive progress test and submitted this to the Erasmus Plus program. Want to join forces and have the ultimate assessment experience in medical education? If so, enroll now.